When we solve or add and subtract, our very first step for solving or adding and subtracting is common denominator. My one denominator is 4x plus 11. The other one is 4. One is a binomial, one is a monomial. If you get one is a binomial and one is a monomial, you can't make them be each other. Okay? The only way you can make them the same is by multiplying them by each other. So I'm going to multiply this one by 4 and this one by 4x plus 11. So if one of your denominators is a monomial and one is a binomial, one term or two, you have to multiply them by each other. You can't make them be each other. Okay? So we're going to distribute the tops. We don't have to distribute the bottoms because they're going to go away, and that is just extra work you don't need to do. All right? So we're going to get 20x minus 4 over 4 times 4x plus 11 equals 12x plus 33 over 4 times 4x plus 11. Now, we actually have denominator equals denominator, correct? The moment we have that, the electric fence can drop, and we can just write the numerators equal to each other. Before we do that, though, we want to state NPVs. 4 doesn't get me 1, but 4x plus 11 cannot equal 0. 4x cannot equal negative 11. X cannot equal negative 11 over 4. I'm going to have to divide. I told you guys specifically that there will be NPVs that are fractions on the test, right? So if you can't do them and you're like, oh man, I can't do them, you have 2 days now. You have at least tomorrow where you can ask how to do them, okay? Because you will have to on your test, and we need to make sure that we can. All right, so we have denominator and denominator. Now we can say, we can drop them bottoms off because they equal the same. We can drop the electric fence and we can just write our numerators. 20x minus 4 equals 12x plus 33. The electric fence is dropped, so now I can cross over the equal sign, right? I can choose to make, put my x's together. I'm going to subtract 12x. And I'm going to get 8x minus 4 equals 33. Then I'm going to add 4. And I get 8x equals 37. And then I'm going to divide by 8. And I'm going to get x equals 37 over 8. Now, you guys are going to freak out when you see 37 over 8. I would freak out if I saw 37 over 8. I'd be like, this isn't just 2 or 7 or 5. This has to be wrong. This cannot be right. I must have done something wrong. That's what I would think inside. And then I'd be like, I didn't. Oh, I really hope I didn't do anything wrong. Remember, you can take the 37 over 8. You can plug it back into the x's and see if left side equals right side. That's one thing you could do. Or 2, y1, y2, second trace 5, enter, 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 and take the x of the intersection, right? It'll give you a decimal, and then you'll take 37 divided by 8, get a decimal, and they should match. And then when they match, you're going to be like, boom, I got this. Drop the mic. 37 over 8. Fantastic. You're not sad anymore. You're not freaking out anymore. You know it is right. You do need to follow behind, though, with x cannot equal negative 11 over 4. Because we have to check and see, is that my answer? Nope, it's not my answer, so it's good. If my answer was the NPV, I'd circle it and say extraneous. Now you should be able to, remember I showed you this, y1, y2, second trace 5, enter, 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 no.
I didn't know there was a button on the calculator.
Yeah, no. Okay, the next one, we have 3 over x plus 5 over 3 equals 10 over 1. All the denominators are monomials, right? All of them are monomials? No. So, because they're all monomials, that means that we can make them all be the same, right? So we have x, we have 3, we have 1. What can we make them all be? 1.
3x.
No one cheating off him on the test. That's all I have to say. If I would take a 50-50 guess at a multiple choice before going on that one. All right. We're going to multiply by 3. We're going to multiply by x. The common denominator is never 1. Unless all of them are 1, which is never going to happen. Because that would not be irrational. You see, that would just be like a nice little...
It's a number.
Yeah. And we're going to multiply by 3x. So we're going to put that one up there. We're going to note to self that 1 is not ever the answer to the common denominator. Locked it? Oh. All right. So we get 9 over 3x plus 5x over 3x equals 30x over 3x. Now we can't drop off the electric fence until we have denominator equals denominator. We agree? So we're going to get 9 plus 5x over 3x equals 30x over 3x. And then 9 plus 5x equals 30x. What are we going to move, my friend?
Divide it. Something. And take the x out. Move it. 5 over.
How do I move it over?
What do you move over the
Subtract it from the,
Yeah.
and then subtract it from the x.
Yep, we're going to do that. So we're going to subtract 5x. You made up for your comment from before. Good job.
Can you just move it all over at once though? No.
You've made up for your common denominator of 1. Right?
I just took that back.
So we're going to get 9 equals 25x. And then we're going to divide by 25.
Oh. Wait, but I still, but yeah, I still got the right answer, but
And you just did more steps. Totally fine.
Does it matter though, like if
Nope.
I do that on the test?
Nope. As long as you got the right answer. So we have, yeah, you're totally fine as long as you get it.
Okay.
So we get 9 over 25, and then our NPV is x can't equal 0, which we're good with because it doesn't equal that. y1, y2, we could type that into y1, y2, the original, correct? Second trace 5, enter, enter, enter. We only take the x value. We only care about the x value of the intersection, right? We don't care about the y. Okay, this one we have a monomial x, we have a binomial x plus 1, and then we have 1. Can we make monomials be binomials? No. So we're going to have to multiply the x by x plus 1, the x plus 1 by x, and equals 6 by x and x plus 1. So we're going to get 4 over x, and we're going to multiply it by x plus 1. And then we have plus 6x over x plus 1. So we multiply this one by x, and then we multiply this one by x and x plus 1. So here we get 4x plus 4, and we don't distribute our denominators because there's no point, plus 6x squared over x plus 1. And then I told you this last day, and you have to remember this. When you distribute that number in, the moment you hit an end bracket, you stop. So I distribute my 6 in, I hit an end bracket, I stop. So I'm going to get 6x and then x plus 1, like that. So you distribute the coefficient into the first set of brackets, and then you stop, rewrite second bracket, distribute. Okay? That 6 does not go into all of them. It stops at an end bracket. Now we have to put this side together first because we can't drop them off because they're still an electric fence because we don't have common denominator over here. So we get x plus 1 over 4x plus 4 plus 6x squared equals 6x squared plus 6x over x plus 1. Now do our denominators match?
Yep.
Yes. So before we drop them off, we say to our NPVs, x cannot equal 0 and negative 1. Then we can write numerators equal numerators. So we get 4x plus 4 plus 6x squared. And people freak out because they think they have to use the quadratic formula. But the moment you have two x squares that are the same on opposite sides of the equal sign, we can subtract them off and they're going to cancel. So it actually gets rid of the squared. So I subtract 6x squared, subtract 6x squared, and now they're gone. So I'm left with 4x plus 4 equals 6x, and it's still linear. So I'm going to subtract 4x, and I get 4 equals 2x, divide by 2, x equals 2, x cannot equal 0 and negative 1. I'm okay because 0 and negative 1 are NPVs, and my answer isn't them. Now I could go 4 over x plus 6x over x plus 1 in brackets in my y1, or alpha y equals enter and put in the fraction, which is better. In my y2 I'm going to put 6, and then I go near 2 and I go second trace 5, enter, 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 and it would say x equals 2, and your y is 6. But I don't care that my y is 6, I only care that my x is 2. I only look at my x value when I do the intersection. The last one is actually a quadratic. So I have x plus 3, x minus 3. They're binomials. I can't make them be each other. And then x squared minus 9. If you don't notice something, you're going to be like, wait a second. I have to multiply this one by x minus 3 and x squared minus 9. That just looks ridiculous, right? That looks ridiculously hard and ridiculous. If that is what you're thinking, this is ridiculously hard and ridiculous, think there might be another step to make it not ridiculously hard and ridiculous, because Lepp would not be that nasty. Okay, and I wouldn't. So, this x squared minus 9 is a what? A difference of squares, which is actually the other two. So we have x plus 3, x minus 3. This is already a common denominator over here. This side I just need to multiply by the other ones. So I need to multiply this one by x minus 3. And this one by x plus 3. And do I have to do anything to the right-hand side? No, because it already has a common denominator, right? So I'm going to get 2x minus 6 over x plus 3x minus 3 plus x squared plus 3x. Oh, this is a 2x. This is 2x squared minus 6x. No one corrected me. That's a 2x up there. Oh, I'm just not paying attention.
Yeah.
X minus 3x plus 3. And then it equals 18 over x plus 3x minus 3. And then we have a common denominator, x minus 3x plus 3. Now because this is a plus sign in between, I can just write them out, right? What if this was a minus sign in between? You have to distribute it. So we're going to get 2x squared minus 6x plus x squared plus 3x equals 18 over that denominator. Now I have common denominators, so I'll be able to drop them off, but before I do that, I have to state their non-permissible values. So now I have 2x squared minus 6x plus x squared plus 3x equals 18. Now in the quadratic formula, it says it has to be in the form for ax squared plus bx plus c equals 0. It has to be in that form. So I have to do what first? Combine the x squareds and move that 18 over. Yeah. So I'm going to get 2x squared plus x squared is 3x squared. Minus 6x plus 3x is minus 3x. Minus 18 equals 0. And then I have my a equals 3, my b equals negative 3, and my c equals negative 18. So I'm going to get x equals minus a minus 3 plus or minus negative 3 squared minus 4 times 3 times negative 3 all over 2 times 3. The minus becomes a plus. So I get x equals 3 plus or minus. When I punch that into my calculator, what do I get? And when you square root that, it's 15. What's that? What do you mean? It's not a 3? No, it's negative. It's 100% a negative 18. Guys, I'm recording, which means everyone can hear everything you're saying. Just so you know, like type 2 in. Okay. So, you're going to get x equals 3 plus 15 over 6. X equals 3 minus 15 over 6. x equals 18 over 6, which is 3. And x equals negative 12 over 6, which is negative 2. There's a catch with this one, though. If I go x equals 3, comma, negative 2, and then follow behind with my NPVs, what's my problem?
It's 3.
It can't equal 3. So we have to go x equals 3.
The 3 is the bad thing.
Okay, the 3 is the bad thing.
The only thing that she noticed.
The only thing she said was x equals 3, but
No,
it's...
I just said it's 3.
Oh, 3 is the bad one.
3 is the bad one. It can't be 3.
So we put, paying attention, extraneous. You circle it, put a line through it, and put extraneous. You have to do that in order to get full marks. And then we're going to say x equals negative 2. X cannot equal plus or minus 3. So my next questions are simplify. They're all going to be simplified. How do you know what to do? Well, you'll either simplify it straight up because it'll have simplified, or it'll be an addition, a subtraction, a multiplication, or a division. And how do you know? It has symbols. It has a plus sign, okay? So 1 is 12p squared minus 8p over 6p cubed minus 4p squared. Plain old simplified. Now this is the catch. If you have to simplify, multiply, or divide, all the same steps. Numerators, denominators, GCF, difference of squares. Every single one of them. So if it's a simplify, plain old one like this, a multiply or a divide, we go to every numerator, every denominator, GCF, difference of squares. Every single one of them. Addition and subtraction and solving, we make common denominator. That's our first step. So multiplying, dividing, simplifying, GCF, difference of squares, every numerator, every denominator. Adding and subtracting and solving, first step is common denominator. So there's 2 different steps. That's it for all of them. So that's number 1. Number 2 is 15x minus 5x cubed over 3x squared minus x4. Number 3, 6x cubed over 27x to the 4, bracket 18x squared, or x, or 15. What happens when you have 2 brackets touching? What is that? I just gave it away. What is that multiplication? Yes, it is. Good job. Nice to know. X. I was coming back. You sounded so sad. No. Stop. 4. 6y minus 30 over y minus 1 times 5y minus 5 over 3y squared minus 15y. And then 5, 2y cubed minus 4y squared over 3y squared minus 9y divided by y squared minus 4, y plus 2y minus 6. I'll give you 10 to 15 max. Go. So the first one is just a simplified question. So the first step always is to GCF difference of squares, the tops and the bottoms, right? Whether it's simplifying, multiplying, dividing. Actually, every single question on this page right now is your steps are to GCF difference of squares, all the tops and bottoms. That's your very first step on every single one of these questions. Okay? So the top here, I can take out a 4 and a p. I can put them in their own brackets. And then I'm left with 3p minus 2. The bottom I can take out a what? 2 and a p squared, which I can write as p squared, or I can write as 2p's separately, side by side, right? Then I'm left with p, I'm left with 3p, not left with p. I'm left with 3p minus 2. Now before I go and try and cancel these off, I must state non-permissible values, right? First step, GCF difference of squares, everything. Non-permissible values, cancel, write what's left over, right? Okay, so I have p can't equal 0. And then this one, if I solve it out, P can't equal, move the 2 over and divide by 3, 2/3. I really hope that didn't record. The brain's strong in that one. Okay, so we have 2 over P. P can't equal 0 and 2/3. Number 2, what can I take out of the top? A 5 and a x. Please make sure you have equal signs running down the sides. The only one that you don't have equal signs running down the sides is solving, because solving has an equal sign running down the middle. So we don't put one around the side on solving, or you'll lose marks. So on solving, there's an equal sign running down the middle, you just run it there. If it's addition, subtraction, simplifying, multiplying, dividing, it runs along the left. Solving, though, runs in the middle. So we have 5 and an x, and then we have 3 minus x. On the top, squared, sorry. On the bottom, we have take out an x squared, so an x and an x. And we're left with 3 minus x squared. Now, x can't equal 0 is my MPV. The other one's the one that people get wrong. So you have to go 3 minus x squared can't equal 0. Move the 3 over, so negative x squared can't equal negative 3. Divide by negative 1. X squared can't equal 3. And then you square root. And when you take the square root, you guys, you have to remember the plus or minus sign. Every time you take the square root of anything. So we get x cannot equal plus or minus 3. Root 3. Root 3. Root 3. Okay? So it's 0 and plus or minus root 3. Whenever you physically take the square root with your own pencil or pen, you have to put a plus or minus sign in front. You'll get 2 non-permissible values. The 3 minus x squareds cancel, the x's cancel, and I'm left with 5 over x equals, and then x cannot equal 0, and plus or minus root 3. This next one's a monomial. When it's a monomial, we can do brackets like this if we want, or we can actually expand it out. So we can go 6 times x times x times x over 27 times x times x times x times x times 18 times x over 15. Now remember, when we have a multiplication symbol and we've done all the reducing we can just go like this and make it all one numerator and all one denominator. Anything that matches on the top and the bottom can cancel. So an x and an x cancel, an x and an x cancel, an x and an x cancel, an x and an x cancel. Then I can reduce the numbers, or I can just multiply them, then reduce them. 6 times 18 is 108. 27 times 15 is? 405. And it reduces to? 4 over 15. X cannot equal 0. I don't know why I boxed the 108, but enjoy. So everything cancels off but the numbers. This one, I can take a 6 out of the top, and I'm left with y minus 5 over y minus 1 times, take a 5 out, I'm left with y minus 5. Take a 3 out, and I'm left with 3y. A 3y out, and I'm left with y minus 5. Because it's multiplication. What? Oh, yep. So because it's a multiplication, I can just write over one denominator, one numerator. My MPVs are going to be 1, 5, and 0. The y minus 1s cancel. The y minus 5s cancel. And then I'm left with 30 over 3y. And then I can take a 3 out of both of those. So I'm left with 10 and a 1. So it's 10 over y. Y cannot equal 1, 0, or 5. The last one is a division. Division, what do you have to do? Flip the second half and multiply. And you have to say NPVs for everything but the top left. So that's my NPV question. Like I said, if I'm going to ask you an NPV question, it's going to be probably a division because you have to state it for all of them except for the top left. So I'm going to take a 2y squared out. So 2yy. And I'm left with y minus 4. On the bottom, I can take a 3y out. I'm left with y minus 3. Then I'm going to flip it and reduce at the same time because I'm a rebel. So y plus 2, y minus 3 goes to the top. Y squared minus 4 is the difference of squares, so I get y plus 2, y minus 2 on the bottom. Now I have to state, I can go with this, boom, and state NPVs, but it has to be for everything but this top left. So I have y can't equal 0 for the y here, 3 plus or minus 2, and then negative 2, which I already did, and 3 I already did. Yeah.
On the top left, it should be y minus 2. And,
Yes, it should be. I made a different color to show I sucked. Okay, good. So y minus 2 cancels off the y minus 2, y plus 2, y plus, ooh, so many things canceling, look at this. 2y over 3. Would have sucked if I didn't fix that. Y cannot equal 0, 3, plus or minus 2. So remember, the only way we can solve them is if they actually say solve, and then we can go y1, y2 because they have an equal sign in the middle. These ones we just have to simplify. Okay?